Hi everyone. So today we're going to talk about wheels and tires theory. The contact between the tire and the road surface plays a large role in determining how a vehicle handles and rides. Today's newer lightweight vehicles are more sensitive than ever to minor tire or wheel issues. Tires by themselves have very little rigidity, so we need something to give it its structural strength, right? That's why we have the wheel. So wheels are very rigid and have no way of absorbing the unevenness of the road surface. So then that's why the wheel has the tire to kind of soften the blow. And tires on most passenger vehicles are called pneumatic tires, and that's because they're filled with air. Recent vehicles use tubeless style tires. So before, older style vehicles, they used to use a tube inside of the tire itself, kind of like bicycle tires. The air pressure gives the tire its shape when the weight of the vehicle is sitting on it. During cornering, centrifugal force acts on the vehicle to produce a side force. The side force is the pressure on the wheel that pushes it towards the outside of or the inside of the rim as the vehicle makes a turn. When the roads are slippery or the vehicle is traveling too fast, the tire is unable to grip the road surface adequately to generate enough friction to overcome the side force. The tire provides the opposing force by being able to distort while still gripping to the road. When a vehicle is driven into a turn with a decreasing radius, both slip angle and cornering force increases until the tire slides. Slip angles depend on the weight distribution within the vehicle, the wheelbase, the tire track, and the overall length of the vehicle. During cornering, centrifugal force puts more weight on the outside wheels, and acceleration puts more weight on the rear wheels. And deceleration or braking puts more weight on the front wheels. The balance point of the entire vehicle. Its actual position depends on the location of the engine and transmission. Static weight distribution is changed laterally by centrifugal force when the vehicle is turning and in a force before and after during acceleration or braking. The wheel itself. The rim of the wheel is the outer circular lip of the metal on which the inside edge of the tire is mounted. So here we have the lip of the rim or the rim of the wheel. Rim width is the distance across the inside of the rim. Flanges at the bead seat. The bead seat is the edge of the rim that creates a seal between the tire bead and the wheel. Rim flange is the exterior lip that holds the tire in place. Rim diameter is the distance across the center of the rim from bead seat to bead seat. In some stock wheels, the drop center is closer to the front side of the wheel. In deep dish wheels, the drop center is closer to the rear of the wheels. So here we have a wheel with a drop center closer to the inside of the wheel. So normally when you get a wheel like this, you would have to flip it over on the tire machine so that you can replace the tire. The way you mount it would be differently. And that's so that you don't damage the wheel and so that you always have to be aware of where that drop center is. It's very important. The offset of a wheel is the distance from its hub mounting surface to the center line of the wheel, typically used to bring the tire center line into close alignment with the larger inner wheel bearing. And here we have negative, 0, and positive offset. Wheels are fastened to the rims by wheel studs and lug nuts, highly stressed by loads, made from heat-treated, high-graded or high-grade alloy steel. Types of wheels retained stud or nut include tapered seat, flat seat with washer, and flat seat without washer or ball seat. And here we have different kinds of lug nuts. When you're dealing with these kinds, the one up here, the tapered seat lug, you have to be careful when you're mounting them because they are open on both sides. You can actually put these on backwards. And you see how it's tapered right here? That's basically so that when you tighten it up against the rim, it kind of centers everything in place. All right. Most lug nuts and studs are right-hand threaded, but you do get some that are left-hand threaded, like this one that we have in the picture here. And usually you can tell because like this one has an L, or they have a little slit cut into the side of the lug nut. The wheel center is the part of the wheel containing the holes for the lug studs. The wheel center also provides the required offset from the center line of the wheels to the face of the mounting flange. Bolt pattern, and right here we have our bolt pattern. Basically, it refers to the number and spacing of the lug nuts or wheel studs on the wheel hub on the wheel rim. The number of studs determine the pattern. The exact number and pattern of the studs vary depending on the vehicle type and manufacturer design. So here we have a 5-lug wheel. And again, the vehicle, the pattern is very important because it's also going to tell you how you're going to tighten the lug nuts, right? So when we're torquing down or tightening lug nuts, we always want to do the star pattern design. So basically, let's say I start here, then I move across down to this one, torque that one down, move across, this one, torque that one down, move across, this one, and torque that one down, then move across. And that's our star pattern. The reason you don't want to go in a circle is because when you start tightening this one down, and then you go to move on to the next one, you start to put pressure just on one side, and then it'll start raising the other side, and it could cause the wheel to get kinked while you're torquing. So when you're doing like if that does happen once the customer starts driving the vehicle or you start driving the vehicle, there's a possibility that it's going to be loose once it starts turning and the wheel can fall off or the studs can be broken off. So to apply even pressure, you want to go start on one side, go across, and then cross and cross. All right, so the air in the tire supports the vehicle's mass, and the tire tread provides frictional contact with the road surface. Cords of the synthetic strands or fabric have high tensile strength. Fewer plies make the tire more flexible. And here we have the layers of the tire with the belt, the inner liner, the bead, which is down here, the carcass itself, the sidewall, shoulder, capli, tread, and groove. Valve stem allows a tire to be inflated and then automatically closed to prevent air from escaping. And this is like a blown up version of the core itself inside of that valve stem. A valve core is threaded into the valve stem and they call it a Schrader valve. A valve stem cap is used to keep debris out of the valve stem itself. Two types of tire construction, there's bias ply and radial ply. Radial tires are by far the most common ones nowadays. Bias ply tires, their body ply cords extended diagonally from bead to bead at 30 to 40 degree angles with successive plies laid at the opposing angles. Design provides a strong, stable casing, but with relatively stiff sidewalls. Stiff sidewalls can distort the tread and partially lift it off the road surface while cornering. There's 2 or more layers of casing plies. Then we have the radial tires. Body ply cords are laid across, the tread extending from bead to bead, and the cords end up parallel to each other at approximately 90 degrees to the center line of the tread. They're extremely durable and maintain good traction. Flexible sidewalls because of their construction as well. They also tend to run cooler than a comparable bias ply tire when properly inflated. Now we have different tread patterns, which give manufacturers the ability to design tires for special applications. There is a directional tread pattern designed to provide a range of attributes during particular driving conditions. Non-directional tread pattern, those are designed in such a way that the tire can be mounted on the wheel for any direction of the rotation. Symmetric tread pattern, they have the same tread pattern on both sides of the tire. Asymmetric tread patterns have a tread pattern that is different from one side of the tire to the other. And then there's directional and asymmetric tread patterns, or both directional and asymmetric. All tires meeting legislative codes must have the following information clearly marked on the sidewall. They need to have manufacturer or brand name, International Organization for Standardization, the ISO tire class, section width, and the aspect ratio. They also need to have type of tire construction, the wheel diameter, speed rating designation, maximum air pressure, the load index, uniform tire quality grading, the UTQG system code, Department of Transportation compliance symbol, and serial number including date of manufacture code. The vehicle manufacturer designates the recommended size and load rating of the tires to be used on each vehicle. The bead diameter must match the rim diameter. The section width must be suitable for use on the rim, and the overall tire size must allow sufficient clearance. The aspect ratio of a tire is the ratio of its height to its width. The lower a tire aspect ratio, the wider the tire is in relation to the height. Low profile tires have very short sidewalls and can be difficult to remove and install. And actually, one of the things we do in the class during lab is replace a low profile run flat tire. And that's the one we're going to be using for our hands-on assessment. The UTQG rating provides information on tread wear, traction, and temperature. Tread wear grade comes from testing the tire in controlled conditions. The traction grade is a letter-based indicator system based on the tire's ability to stop vehicles on wet concrete and asphalt in straight line situations. The temperature grade of a tire is a letter based on the test performed by the tire manufacturer and overseen by the US government. As part of DOT regulations, a tire manufacturer date code must be stamped on the sidewall of every tire. A 3 or 4-digit code denotes when the tire was manufactured. Never use tires more than 6 years old. Normally, that's kind of like the rule of thumb. Now here I have a tire with the DOT number, and I want to show you guys where exactly that code is. So normally on the tire itself, there's going to be 2 DOT numbers, stamped one on each side of the tire sidewall. So you're going to look for the longer DOT number, and then once you find it, you're going to go all the way to the end. So this number right here is what tells you the date of when the tire was manufactured. This is like these letters over here, that's like the plant code and like all this like regulation stuff. Over here is where you'll find the date itself. So this tire, if you see, it says 5107. That means that this tire was made the 51st week of 2007. So the first two numbers are the week of the year, and then the second two numbers are the year itself. Tire safety features. A tire pressure monitoring system is used to monitor the air pressure in each tire and warn the driver if one or more tires are low. Run flat tires are designed to be driven for a reasonable amount of time when the tire pressure is low or empty. Then we have the self-sealing tires, which resist leaks and help maintain air pressure. And then a spare tire is designed to be used for reduced speed and distances so that a driver can get the vehicle to a service facility. So the tire pressure monitoring system, in addition to increased fuel consumption and tire wear, long periods of driving with low tire pressure can cause additional stress on the tire sidewall. Underinflation can lead to a tire blowout or tread separation. The Automated Tire Pressure Monitoring System, or TPMS, provides a means of reliable and continuous monitoring of the vehicle tire pressure. And here we have the different types of tire sensors. This one goes on the actual rim itself. And if you see here, they all have like this little hole. That's where it takes the reading from. Now, normally when we're replacing tires, I always like to assume that the tire has a sensor. And the reason being is if you see these two sensors from the bottom, I mean, they kind of like they have the housing, they're kind of like similar, but the actual valve stem, this one has an aluminum housing and this one has a rubber housing. The rubber housing tends to look like just a regular rubber valve stem that doesn't have a sensor. If you look at tires, and you see these, it just kind of looks like there's nothing there. But as you can see, once you go further down, like you have an actual sensor mounted. So when you're removing that tire, there's a possibility that depending on how you remove it, if you don't do it right, you can break that sensor. Tire pressure monitoring system monitors the tire for low air pressure and alerts the driver when one or more tires are lower than, or in some cases higher than, the designated threshold. Designed to ignore normal pressure variations caused by changes in ambient temperature. So like when summertime comes in, usually the pressure in the tire changes a little bit because of the heat. So it'll start to send like turn on your light or things like that. Or let's say when you're ready to turn on your car in the morning, the tires are nice and cold. But then once you start driving it, and if you're driving long distance or a lot of stop and go, your tires tend to get hot. And as they start to get hot, the pressure inside of your wheels increase. So normally, if you're checking your tire pressure when the tires are hot, I always like to compensate a little bit and add like 2 more PSI, because once it cools down, the pressure is gonna go down further. Two basic configurations to monitor the vehicle's tire pressure: direct and indirect. The use of centrifugal the use of centrifugal the use of centrifugal switch in the sensor allows the sensor to go to sleep when the vehicle stops. A direct TPMS can be of two types. In one way communication, the TPMS sensor can only transmit to the receiver. In a two-way communication, the TPMS, the sensor can receive as well as transit signal. And an indirect tire pressure system monitoring uses an analog braking system to measure the difference in the rotation speed of the four wheels. So this would be a direct type of system because we have actual sensors mounted on the wheel that's constantly checking the pressure on the wheels. The indirect, that's when you're using the wheel speed sensor and it's checking how fast that wheel is turning. So if it sees that, let's say 3 of the wheels are going a certain speed, but then the fourth one, if senses that it's spinning with a little bit more resistance, then it's gonna think, all right, cool, there's something wrong with this tire. So let me throw off a light and have the driver check it real quick just to make sure that it's not leaking. So it looks for that resistance and the speed of the wheel. Run flat tires. As you can see in this picture, the sidewall is a lot thicker. And that's so that the tire itself can support the weight of the vehicle. So we're not using, once this tire goes flat, we're not using the pressure inside of the tire. We're using the actual sidewall to keep the car up. It enables a driver to maintain vehicle control if a tire suffers a rapid pressure loss when in motion. Enable the driver to continue the journey within specified speed and distance limits. TPMS is normally mandatory for all run flat technology applications to monitor the drivability of the vehicle's run flat tires. And that's because since your tires are not going flat, then you, as a driver, you don't feel it when there's no air in the tire if you do get a nail. Generally 2 to 3 times heavier than their conventional counterparts. The design features of a run flat technology generally focus on 2 aspects of operational use: rigidity and heat resistance. So EH2 rims have a wider or more extended safety hump than a standard safety rim. So the thing is about a run flat wheel or a run flat tire is that you need a run flat rim. On a run flat rim, the lip or the seat where the tire bead sits on, like right here and right here, it's a lot more defined and it's deeper. And that's so that it can hold the tire bead in place in case it is flat, then it'll sit on the air. Usually if you have air in here, then it kind of just keeps it in place with the air. But once it goes flat, if this was a regular wheel, then the bead on this side will kind of fall over once you start driving. So when you're replacing tires, you can use a non-run flat tire on a run flat rim, but you can't use a run flat tire on a non-run flat rim. Ooh, that's the first time I get it right. I always tend to like mess it up and like confuse them, which I'll probably do once you see me in the classroom or in the shop. For some reason, that's like the it's like a tongue twister to me. All right, so let's move on. Self-sealing tires, as you can see here, if we were to get a nail, it has a layer of sealant or flexible malleable lining. When you get the nail, it kind of tends to hug the nail, and then if you were to pull it out, it takes some of it out with it and fills up the hole. This is designed to repair most small tread area punctures instantly and permanently. Features standard tire construction with the addition of a flexible and malleable lining inside the tire in the tread area. Provide a seal around the object when the tire is punctured, and then fill in the hole in the tread if the object is removed. Still requires a TPMS to detect any low pressure conditions. In 2008 or newer vehicles, that's when they kind of started mandating that. And then we have our Space Saver spare tire. This is designed for emergency use only, designed to get the driver to a service center to have the regular tire fixed or purchase a new one. Normally required a specially charged canister for inflation when being installed. So now all these types of spares or these type of systems like the run flat tire, the self-sealing tire, and the Space Saver or the spare tire, they're all meant to get you from the point where your tire goes flat to a service center where they can go and fix it, right? They're not meant for you to be driving for long periods of time. They're not meant to like, oh, it goes flat, I still have like 1,000 miles to go or like a month to go. No, like they're meant for you to, as soon as they go flat, you take it over to a service center and then you get it replaced or repaired. All right, so that's it for this chapter. Thank you guys for watching, and I'll see you guys in the lab.